Hi, Assalamualaikum. And my name is Muhammad Fakrul Mustaqim bin Muhammad Azrul Nasri. Welcome to this walkthrough on using simplex method to optimize a financial investment portfolio. We have a firm investing in three assets: stock, bond, and mutual funds, and we want to maximize the weekly return while respecting investment risk and liquidity constraint. Expecting weekly return per 1,000 invested in stock for 200, bond 120, mutual fund. So for this is a form as the following constraint that we will be using for our simplex methods. For the answer, let's for the step 1, define decision variable. We define our decision variable as follow: as A equal to represent in stock, B represent in bond, C represent in mutual fund. So the objective function is stock, which is A equals to 200, bond which is a B equal to 120, mutual fund which is equal to 160, and the weekly per return is 1000. The next step is formulate the LPP. Our objective is to maximize weekly return. So we will be using this formula. Z equals to 200A plus 120B plus 160C. Meanwhile, the constraint is the total investment A plus B plus C less than 1000. For the risk exposure, 5A plus 2B plus 3C less than 3000. Liquidity requirement is 2A plus B plus 2C less than 1500. Non-negativity is A, B, C less than 0. For the next step, standard form, which need to add a step variable for the total investment, for the risk, for the liquidity. So the new objective of function is Z equal to 200A plus 120B plus 160C plus 0 x1, 0 x2 and plus 0 x3. Meanwhile, the new standard form is A plus B plus C plus x1 and equals to 1000. And after that, 5A plus 2B plus 3C plus x2 equals to 3000. 2A plus B plus 2C plus x3 equal to 150. So I will pass next to my friends.
Assalamualaikum warahmatullahi wabarakatuh to Madam Hanisa. My name is Ahmad Zainul Kamil Hashim, and today I'm going to continue the presentation for the question 5. Now, before I start my question 5, I want to do a simple recap, which is we already identified the variables for our table, which is A, B, C, and our select variable, which is x1, x2, and x3. These variable is very much needed to create a simplex table. I will show you the table on screen, and as you can see, all the information that we have collected from previous question, we put it in the table to calculate ZJ, CJ minus ZJ, and the ratio. So now, before we start our first iteration, we have to identify which one is the entering variable and which one is the leaving variable. Now, as we look at the Cj minus Zj row, we can see that the most positive value is 200. So then we know that the entering variable is A. So now we already identify which one is the entering variable. Now let's identify which one is the leaving variable. Now, to identify which one is the leaving variable, we have to compute the ratio, which we have to calculate the ratio. So as you can see, when the calculation has been made, that x1 ratio is 1000, x2 ratio is 600, and x2 ratio is 750. So now we know that x2 ratio is 600 and it is the smallest positive ratio, and that is our leaving variable, which is x2. So x2 is the leaving variable and A is the entering variable. Now we have all this information, we can start our next operation, which is what we call pivot operation. Pivot operation is what we do to update the table. Okay, as you can see, we have done all the calculation here. So then we know, after completing all row operation, we get the updated table for iteration 1. So now in this table, the entering variable is B and the leaving variable is row 1, which is the x1 row, and the pivot number is 2/5. That is my part in this presentation. I'm gonna pass this next one, which is the second iteration table, to Muhammad Akil bin Hijay. Thank you.
Okay. So, Assalamualaikum warahmatullahi wabarakatuh to Madam. So, my name is Muhammad Akil. So, I'm going to continue from Aiman Zarif part, which is the second iteration. So, firstly, we need performing the pivot for the second iteration, which is given after the updated tableau, which is the basic variable A, B, C, x1, x2, x3 solution and ratio based on the board given. So after all the calculation, we found out that in the second iteration, all the solution are optimal because all the numbers at the Cj and Zj which is smaller or less than 0, which is it means that it is optimal. So the optimal investment are stock, which is A, equal to 500, bonds, which is B, equal to 500, mutual fund, which is we know as C, is equal to 100. So the maximum expected weekly return is Z equal to 200 times 500 plus 100 times 500 plus 160 times 100 is equal to 180,000. So the firm should allocate 50% of funds to stocks, 50% to bond, and a smaller portion to mutual funds. This maximizes returns while staying in the investments, risk, and liquidity constraints. So in the summary, we define decision variable for the investment portfolio, formulated the LPP and converted into standard forms, constructed the initial tableau, identified entering on and leaving variables, and also performed iterations, found the optimal solution that maximizes weekly return while satisfying all constraints. And this is showing that we demonstrate the practical use of the simplex method in portfolio management. So thank you for watching, and I am sorry if there were any mistake by us, which is Aiman Zarif, Farkul Mustaqim, and me. And that's all from us. Thank you.